Hey guys, welcome back to my channel. In this video, we'll be covering the basics of trigonometry for grades 9 and 10, right? So if you're starting with trigonometry or you want to revise the whole trigonometry in one video, there'll be no questions done in this video. All the basic concepts and all the little parts that you need to remember or know about trigonometry will be told in this video, okay? And if, for example, you're in 9th, okay, you haven't studied trigonometry all year long, this will be your one-stop guide for trigonometry, okay? Everything is going to be covered in this video, and even if you're in 10th, you can refer to this video because the basic concepts remain the same, okay? And if you're starting with trigonometry, you can still refer to these videos to get a basic understanding before you attend your lectures, or you can just refer to these videos as well, okay? For grades 11 and 12, there will be another video, okay? And this is just the school time basics, grades 9 and 10. So let's start. The first thing we know about right angle triangles is the Pythagoras theorem. So Pythagoras theorem, the basic requirement is a right angle triangle. This is your right angle right here, okay? And this is the height of a triangle, this is the base of your triangle, and this is called the hypotenuse. This is called the hypotenuse of your triangle. Let's say your triangle is named A, B, C. As per Pythagoras theorem, if your triangle is named as ABC, this side here, BC will be A, AB will be C, and AC will be B. The name of the sides will be as such. So if angle A is here, the side opposite to this angle will be your side A. Alright. So now, if you are starting with the Pythagoras theorem, the main thing about Pythagoras theorem is the Pythagoras formula. And what does it say? It says a square plus c square is equal to b square, meaning sum of squares of the two smaller sides is equal to the square of the longer side or the hypotenuse. And how do you actually write it? We write it as ab the whole square plus bc square is equal to AC square. Okay, you have to use the lengths. So AB square means the length of AB square, BC square means the length of BC square, and AC square means the length of AC square. Okay, now moving on, we'll start with actual trigonometry here. Okay, so what do we need to know while beginning with trigonometry? So here the main thing we require is a right angle triangle again. Your entire trigonometry is based off of this triangle. You need to know what this is. This is your right angle here, and let us name our triangle as A, B and C over here. Okay. So now, for example, this is your right angle and you have unknown angle over here. In trigonometry, we'll be naming this angle theta, and the entire game is with this theta. Right now this is unknown. In the future, even when this angle is known, this angle here is known, you will be asked to find the some particular function of that angle, or you will be asked to perform some calculations based on this angle. So this angle is of utmost importance. So now let's see, if this is 90 degrees and this is theta, what will be the measure of this angle? So we all know by angle sum property of triangles that the sum of these angles is 180 degrees. So let's write that over here. Okay, wait, let's just change the ink. Okay, so we know that the sum of these angles is 180 degrees. So write that down over here. 180 degrees is equal to, so first we know that this is 90 degrees. So 90 degrees. Then we have this angle that we have considered here, that is theta, plus you have this angle over here which you have named question mark. Okay, so if 90 goes on the other side, it becomes 180 minus 90, which is 90, is equal to theta plus question mark. So what is question mark equal to now? Question mark is equal to 90 degrees minus theta. So we'll replace this question mark with 90 degree minus theta. Okay, so now what are the basic things that we need to know in trigonometry? First of all, you will call this the base of the triangle. You will call this, that is AB, as the perpendicular of the triangle. This is the sign for perpendicular. Okay, so even if it's not a triangle and you see two lines forming a 90 degrees, you can call one side the base and the other side or the other line as the perpendicular, and this is your hypotenuse, as you know. Now, we don't really need to remember perpendicular and base. What you can do is you can remember things with respect to this theta over here. If the line is touching theta, you will call it adjacent. Okay, you'll call it adjacent. And if the line is opposite to theta, you will call it opposite. Okay, I prefer using adjacent and opposite because if you remember as base and perpendicular, we are doing that with respect to this theta over here. But what if the theta given to you is this? Right? What if the theta given to you is this theta? What will you do in that case? So in that case, you have to refer to this as base and this as perpendicular. But in case you're given a theta here, you will always know that the line joining this theta will be the adjacent and the line opposite to this theta will be my opposite. Okay. So now let's move on to the main part. What are the main terms that we are going to be using throughout trigonometry here? The main terms we are going to be using are sine, cosine and tangent. So cosecant, secant and cotangent are basically inverse, or you can say 1 upon these functions here. These important functions here are going to be your cosecant, secant and cotangent. But if you remember just 3 of these, your work will be done. These 3 you can just derive from this. Okay, so now sine theta over here, we all know what sine theta is, right? You write it like this. You might have seen this somewhere or the other. So the theta is our unknown angle and sine is a function. What is that function? Sine theta is equal to your opposite upon hypotenuse. Okay, so opposite upon hypotenuse is your sine theta. So and whenever they say sine theta, you will take the length of the opposite side divided by the length of your hypotenuse. Now suppose you have cosine theta. Cosine is adjacent upon hypotenuse. Okay, then you have tangent, which is opposite upon adjacent. So now that we've read or studied all this, you'll be like, how do we remember it, right? So if you're just given opposite upon hypotenuse, adjacent upon hypotenuse, then opposite upon adjacent, how are you supposed to remember it? Very simple mnemonic that many people use. Okay, even I was told about this by my teachers, or some people just figure it out on their own. Okay, you have so, ka, toa. Okay, this seems like a bit of a gibberish to you, but like just remember so, ka, toa. What does it mean? Sine is opposite upon hypotenuse. Cos is adjacent upon hypotenuse. And tan is opposite upon adjacent. Okay. So now we'll take an example over here. Suppose we have a right angle triangle over here, and you have taken this to be your theta. This is 3 centimeter, this is 4 centimeter, and this is 5 centimeter. What will sine be? Now if theta is this angle over here, right? So let us take theta over here, and your theta is this angle over here. Which is the opposite? Opposite is 3, so you will write 3. What is your hypotenuse? Hypotenuse is 5, you will write 5. Now if you are supposed to find the cosine or cos, what will you do? Adjacent first. Adjacent is this 4 because it's touching your theta. So it will be 4 over here upon hypotenuse is 5. Hypotenuse, if you are not able to figure out, just remember longest side is your hypotenuse. You are introduced to this Pythagoras theorem in around grade 7 and 8. Okay. So now in grade 7 and 8, mostly it's used in physics first. Okay, we were introduced to it in physics first. Now it depends. Okay, sometimes it's in maths also. So what it is used for is to find this unknown longer side. It's usually introduced in the topic distance and displacement. Okay, if x travels this much downwards and this much rightwards, okay, they take a sharp turn and cover this much rightwards, how much is the displacement, final displacement. So you have to use Pythagoras theorem for that. In that it is introduced in such a way that two shortest sides का square, उनका sum is equal to the longer side square. Okay, so the longest side is your hypotenuse, remember it that way, or the side which is opposite to your 90 degree. So if this is your 90 degree, okay, you have 90 degree here, this opposite side is your hypotenuse. All right, okay. So now that we have all this, now let's see what will tan be. So again, redrawing our triangle here. This is 3, this is 4, and this is 5. So what will your tan be? Tan is opposite upon adjacent. This is your theta. So opposite is 3, adjacent is 4. So that is going to be 3 by 4. Now if you look carefully, right, you can form that the numerator of sine upon numerator of cos is equal to your tan, right? So what will we do now is we can derive another formula for tan. And what is that? You can say that tan theta is equal to sin theta upon cos theta. Okay, so tan can be written as sin theta upon cos theta. So now let us write all of this very neatly. Okay, I'll just write all these formula neatly, then you can take a screenshot and remember this. Okay, so this is the mnemonic that you have to remember. According to this mnemonic, sin theta is equal to opposite upon hypotenuse, cosine is equal to adjacent upon hypotenuse, and tan is equal to opposite upon adjacent. Okay, now moving on to these three derived, or in my words, secondary functions in trigonometry. Okay, so now cosecant, or what you call cosec. Okay, so you don't refer to as cosecant all the time, you call it cosec. Okay, so this is basically written as 1 upon sine. Okay, so 1 upon sine is your cosec. So if sine is opposite upon hypotenuse, you have 1 upon O upon h. What happens? H goes up, so it becomes h upon O. So even your cosecant is hypotenuse upon opposite. So what is secant? By this very logic or this very sense, secant is h upon a. And what is cotangent? It is a upon O. Now all these forms, right, they are extremely important. Why so? That is because whenever you are solving questions, okay, you have proved that sums or show that sums, they require all of this. Okay, they require cosecant to be converted to sine or secant to be converted to cos, right? So this is how you will be writing all of it. So what will we remember all of this as? You know basically how to form these. We know the mnemonic so, ka. I'll get rid of this because you already done the calculations. Yeah, so you have so, ka, toa. Okay, this is the mnemonic you have to remember and go by if you're not able to by heart these values. Sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan is opposite upon adjacent. And secant here is 1 upon sine theta. Cosecant here is 1 upon sine theta. Secant is 1 upon cos theta. And cot or cotangent is 1 upon tan theta. You have to only know this. It's okay if you don't know what cosecant, you don't know about sine, cosine, tangent, no worries. Just these underline names, if you remember, it's more than enough. So secant will be h upon a, and tan will be a upon cot or cotangent will be a upon o. Now take a screenshot of this. This is all you will have to remember for grade 9, maximum of it. There is one more part though. So you see these co-terms over here, sine, cosine, tangent, cotangent, secant, cosecant. So what is with this co? Okay, so we have to remember that these co-terms, okay, sine and cosine, tangent and cotangent, secant and cosecant, they form composite angles. Okay, so now if you're given sine theta, for example, okay, wait, I'll just increase this space over here so I can explain it to you completely. Okay, so now if you're given, suppose you're given sine theta, sine theta, you can write sine theta as cos 90 minus theta. Okay, and if you have sine theta is equal to cos 90 minus theta, now you also have cosec. Okay, so let us write that as sec. Okay, so if you have sec theta, what can you write it as? You can write it as cosec 90 minus theta. All right, now that you have this, what is the last one? You have tan. Tan theta can also be written as cot 90 minus theta. Okay, you will have to remember these because you know it comes under conversions later on. So we are asked, okay, if you have sine 60, what will it be? And suppose you are only given the value of cos 30. How will you find that? 60 is equal to 90 minus 30, right? So you can write it as cos 90 minus 30. Since cos 90 minus 30 is 60, you can find the value that way. Okay, now once we are done with this, let us move on to trigonometric identities. What are trigonometric identities? They are these three basic equations which help you simplify the terms that you have in an equation. Again, they are very useful when you have to prove that or show that questions. So you need to remember these three. So if you have sine square theta plus cos square theta, you can write it as 1. Okay, and if you have 1 plus tan square theta, you can write it as sec square theta. And if you have 1 plus cot square theta, you can write it as cosec square theta. They're extremely easy. There are just three identities that you have to by heart. Okay, and they're extremely useful when you're doing prove that and show that. So if you want to be able to solve those in a jiffy or very easily, do remember these. Okay, otherwise you can actually derive these two on simplification. Okay, so if you have 1 plus tan square theta, what you can do is it's 1 plus tan square, so it's 1 plus sine square upon cos square, right? So you can take cos square here, so it becomes equal to cos square plus sine square upon cos square. Now you know sine square plus cos square is equal to 1, so it becomes 1 upon cos square. And we all know that 1 upon cos is sec, right? So 1 upon cos square becomes sec square. Okay, and similarly you can also derive this. Okay, if you're not able to derive, do leave it in the comments. I'll show you the derivation of that as well. But if you remember this alone, and suppose you remember 1 plus tan square theta is equal to something, you're not able to figure out what that something is, at that moment you can just find out what it is equal to in this one line. Okay, so now let us move on to the next topic. These identities you have to remember. Okay, they're extremely easy and there's no as such mnemonic for them, but it's actually easy and very easily derivable also. You can derive them on the spot. Now we will get to the crux of this chapter. Okay, important values of theta and their sine, cos and tan. So important values of theta in school are 0, 30, 45, 60 and 90. Okay, these are all you have to remember. Why? Because you can make a table out of these and you will be asked, okay, you will be given equations like what is sine 0 plus cos 45 plus tan 90 plus cosec 45. So you will be asked to put in all these values, plug in all these values and then solve it. Okay. And with this you also need to remember the ones where I told you, sine theta can also be written as cos 90 minus theta. Tan theta can also be written as cot 90 minus theta, and sec theta can also be written as cosec 90 minus theta. Why? Because suppose they give you some very not so beautiful values like 53, 86 or 101. In that case, you should be able to write them in the form of any one function. Why? Because there are chances of that one function, like sines. If you have plus sine 98 minus sine 98, for example, okay, if you have plus sine 98 minus sine 98, you will be able to cancel those off. Okay, so if you cancel those off, it becomes very easy. Many a times, if it's such a non-conventional value, na, they can probably give you answers that end up in a 0 or a 1 or a 90 or some nice values like this. So keep an eye out for that as well, wherever you can simplify. Now you have to form a table of these important values. So make a note of these important values: 0, 30, 45, 60 and 90. And now to find the values, right? To find the value of sine, cos and tan of these numbers, there's an easy trick. Write the numbers from 0 to 4. Okay, write 0 here, write 1 here, write 2 over here, write 3 over here and 4 over here. Now divide all of the numbers by 4. Just write a 4 under all these numbers. Now put an under root to all the values. This is a short trick, okay? Ideally, it's expected of you to remember the values of sine, so you can at least make this table on the spot, but this is a very short trick, okay? So what do? You start up by writing numbers 0 to 4 in every box, divide it by 4 and put an under root over all of them. Now what do you get? 0 by 4 is 0, so under root 0 is 0. 1 by 4 is under root 1 upon under root 4, so 1 upon root 4 is 2. Okay, now you cancel these off, 1 and 2. Root 1 is 1 and root 2 is root 2. Okay, root 3 as it is and root 4 we all know is 2. 4 upon 4 you get 1, under root 1 is 1. So now you found the values of sine. Okay, so let us write all of them nicely. So now that you know the value to all of them, we'll write them directly. 0, 1, okay, wait, 0, 1 by 2, 1 by root 2, root 3 by 2 and 1 over here. Okay, so now how do you find the values of cos? Cos 0 will be equal to 1. You'll have to reverse these values. So whatever was in the last box here will come in the first box over here. Second last box over here will come in the second box. So it becomes root 3 by 2. Okay, and 45 is the third box from left and from right. So it becomes 1 by root 2 here. Then 1 by 2 over here and 0 over here. Okay, so you first have to find the values of sine, for which I give you a trick to write 0, 1, 2, 3, 4 over here. Divide all of them by 4, put an under root above them and get these values. Then you just reverse that table: 1, root 3 by 2, 1 by root 2, 1 by 2 and 0. Okay, now finally time to find tan. For tan, I told you that tan theta can be written as sin theta by cos theta. So here we'll be doing the same thing. So to find tan 0, you'll have sin 0 by cos 0, which is 0 upon 1, that is 0. To find tan 30, you have 1 by 2 upon root 3 by 2, which is equal to 1 by root 3. Then for tan 45, you have sin 45 upon cos 45, which becomes 1 by root 2 upon 1 by root 2. So any number divided by itself is 1, right? Then you have sin 60 upon cos 60. So you'll write it as root 3 by 2 upon 1 by 2. It becomes root 3. And 91 upon 0. Now anything divided by 0 is not defined, right? So how do you write this? You write it as not defined or ND or undefined. Okay, and here you have all the values. So let's write them very neatly now. I have told you the short trick how to find these things. You can use this in your exam. Okay, suppose you don't remember the values, just use this in your exams and you'll be good to go. Don't worry about having to by heart all these values. Take a screenshot of this, okay, and whenever you're not able to remember the values, just draw this table. And if you look at this table, like 3 or 4 times before going, you'll have a vague idea of what values lie where, and you'll be able to find them very easily. Okay, just remember how to find sine, and you're sorted for cos and tan. Okay, now let us understand what basically the angles over here are. For example, let us consider you have to take this over here. Okay, so suppose you have a circle over here, you'll be taking a circle like this. Okay, so if you have a circle somewhat like this, one second, this is malfunctioning. Okay, so if you have a circle like this is your x-axis and this is your y-axis. Okay, so with this, suppose this is 1 and this is also 1. Okay, this is -1 and this is -1 over here. So this is 0 and this is 90. Your angles you can get are up to 180 over here. So over here, if the sine value is 0, right? So over here also sine value will be 0. Over here it is 1. Over here it will be -1. If your cos value is 1 over here, it becomes a -1 over here. Okay, and if your cos value is 0 over here, it becomes a 0 over here as well. And similarly, using this you can find tan values. Many a time it's asked that what is sine 180 or cos 180. To do that, just reverse the sign. Okay, if it's 0, it remains a 0. If it's a +1 over here, it becomes a -1 over here. Now this whole circle is 360 degrees, right? So this is your 0 degrees, this is your 90 degrees, this is 180, this is 270, and then 360. They can also ask you values for 270 and this over here. Just remember that if you know the value for this, the value for its +180 or -180 will be the negative of it. Okay, if it is x over here, the value over here will be -x. If you know 60, right, and if you are given the value of 180 plus 60, okay, so 180 plus 60 will be somewhere around here. Okay, and the value at 60 is by, for example, the value at 180 plus 60 will be equal to -y. Okay, so now this is it for the video. Don't forget to like, share, subscribe, and take the important screenshots from this video. Okay, the important screenshots basically in this video are Pythagoras theorem. We all know. You need the screenshot of this. Why? Because there is a mnemonic over here that you can be using to remember all these values. And what is cosec, what is sec, what is cot. Then this, wherein these are 3 important formulas that you need to remember while solving descriptive type answers, wherein you have to prove or show something. Trigonometric identities, you'll easily find it and you'll be using it everywhere. And you can derive the second and third identities if you know the first one. Okay, just convert them into the basic. So tan theta is sine upon cos, cot theta is cos upon sine. Okay, sec is 1 upon cos, and cosec is 1 upon sine. If you remember this much, you will be easily able to find out the trigonometric identities, that are the second and the third one. The important values of theta, we have done the short trick on how to find the values easily. Showing them again, write 0 here, 1 here, 2 here, 3 here, and 4 here. Okay, divide throughout by 4. 1 by 4 here, 2 by 4 here, 3 by 4 over here, and 4 by 4 over here. Now put an under root over all of them. Okay, once you've put an under root over all of them, you just have to take out their final values. So root 0 is 0, root 1 by 2 is 1 by root 1 by 4 is 1 by 2, root 2 by 4, it can also be written as root 1 by 2 and 1 by root 2. Then you have root 3 by 4, so it becomes root 3 by root 4, that is 2. Then root 4 by 4 or root 1 is 1. Reverse all these values and you'll be able to write cos k values, and then for tan you have to divide sine upon cos. That is a formula that we have written earlier. Okay, and then that's it. For the further topics, it's for grades 11 and 12. Okay, they'll be used in your grades 11 and 12. So that for that I'll be making another video. This will be helpful to all the people who just want to refresh their basics as well. So don't forget to refer to this whenever you need to revise trigonometry. Thanks for watching. Don't forget to like, share, subscribe, and comment down below if you have any queries or suggestions or any particular topics you would like me to make a video on for you guys.